Hi, now we're going to continue with slope. We touched on it briefly as a tool to creating our graphs, but now we're going to get a little bit more into what slope itself is. And as we've discussed already, slope is a rate of change. It's a specific rate of change of the y variable with regards to the x variable. So let's take a quick look. We can, of course, get slope from our equation, m equals 1 over 2. Okay. And that's our delta y over delta x. Now we're saying that delta y is 1 and delta x is 2. So for every 2 units increase in x, we get a 1 unit increase in y. That's what that means. Okay. So we have a variety of ways of finding the slope, and we're going to look at 3 different ways today. So we can find slope from the equation, from a graph, from a table of values, a TOV is a short form for it, from a table of values, and also from 2 points. From the equation, we know how to do that. You just look at it, find m, you're done. From the graph is a little bit different. So I'm going to actually graph this y equals 1/2 x plus 2. I'm going to graph it really quickly, and then we're going to look at how we can use the graph and work backwards. So just pretend you don't know what the equation is. Suspend disbelief. Okay, so it's 1/2 x plus 2, so plus 2 is our b value. 1 over 2 is our slope. So that looks like that. I'm going to make that go both directions. Okay. Just give me a second. Okay. So now I have my line. Okay. So from the graph, we're going to look for rise over run. Rise over run is something that you'll hear a lot. We say, oh, slope is rise over run. Slope is rise over run. Rise just meaning the up-down, and run meaning the horizontal. So the reality is rise over run is just a simple, catchy way of saying delta y over delta x. It's kind of the same thing, but we like to use it when we're looking at the graph. So let's look for the rise over run. What we're going to do is we're going to select 2 points where the relation crosses the lines perfectly. So let's look at this one. That's a nice point, and that's a nice point. So I'm going to look at how does the y value change between these 2 points. So if I look at the change in y, 1, 2. So the change in y is positive 2. And what's the change in x? So between those 2 points, I move positive 4. So my rise is 2 and my run is 4, both positive. So m here equals 2 over 4. Am I done? No. It's not in lowest form. Remember, all fractions must be in lowest form. It doesn't matter if we're in 1, 2, 3, 4, 5, whatever. Fractions have to be in lowest form. So that actually equals 1 over 2. Oh. Do you think it matters which 2 points I choose? It doesn't. If I'd chosen, pick another color here. If I'd chosen this point and looked at the change here, I'd have 1 and 2, and I'd get 1 over 2 right away. So you don't have to stress when you're looking at the lines. Sometimes it can be hard to find exactly the perfect 2 points to use. So when you're stressing about that, pick any 2 good points, and you'll get the right fraction, and then when you reduce it, you'll have the correct slope. So just to let you, to refresh you, when you're looking at a point, you want one that crosses right at one of those junctions between all of the grid lines. Those kinds of points, okay, are ones that have an actual value. They have an actual numerical value. Never pick a point in the middle. Never say, oh, I'm going to use this right there. No. You have to estimate. You have to say, oh, it's like minus 3.4. I don't want to estimate the point. I want to know the actual slope. If you estimate, you're never going to get exactly the right answer. Not in this type of a question. So you have to make sure you're using a point that crosses right on those grid lines that gives you a whole number numerical point, or maybe your scale is going up by 0.5s, is an actual definite certain 0.5. Something like that, depending on your scale. But you must use a number that you're not estimating, a number that you know for sure. Okay. What about a table of values? How would we work this from a table of values? So we know from a graph we use rise over run. We just find 2 points, make our little right angle triangle and say what's the change in y and what's the change in x. Let's look at a table of values. So I'm going to create a table of values. I'm going to create it from, obviously, this equation so that we always know we're on the right track. I'm going to do minus 4, minus 2, 0, 2, 4. Remember I said you can pick any x values you want. Minus 4 divided by 2 is 2. Minus 2 plus 2 is 0. Minus 2 divided by minus 1. Minus 1 plus 2 is is 1. Yeah. 0. Hold on. Okay. It's 2, 3, 4. Sorry. My mental math took a little while to kick in there. So here is my table of values, and I want to find my slope. I have 2 different techniques that I can use. I can look at what we call the first differences. So what I'm going to do is I'm going to draw an extra column on either side, and that's going to be the change in x, and that's going to be the change in y. And I can look at what this changes from negative 4 to negative 2 goes up positive 2. Positive 2, positive 2, positive 2, and from here it's going up plus 1, plus 1, plus 1, plus 1. So if m equals delta y over delta x, I take these numbers and I just substitute them in, and I say m equals 1 over 2. That's not too bad. So far we have 2 techniques. We can find rise over run off the graph, or we can look at the first differences. Okay, put these in here. We'll call these the first differences, and substitute that in for delta y over delta x. There's another one we can do as well, and I'm going to use a different example for that. We're going to come down here. We're going to look at this example here. Back to blue. And we know just from looking at the equation that m equals negative 2 over 1. So I'm going to create another table of values. Okay, and then I'm going to show you a very important technique using 2 points. So if x equals -2, -2 times -2 is +4, +4 minus 1 is 3. If x is -1, -2 times -1 is -2, -2 minus 1. Oh, I hope you guys caught that. Everybody makes mistakes. Let me try that one again. -2 times -2. No, I'm right. +4 minus 1 is 3. My apologies, I doubted myself. -1 times -2 is +2. +2 minus 1 is 1. Minus 1 minus 3. 2. That's 4 minus 1 minus 5. There we go. Whew. Okay. Now, I'm going to give you an equation for slope that always, always, always works. You should memorize this. I'm even going to write it in red. It's really important. M equals y2 minus y1 over x2 minus x1. That's a very formal equation for slope. And the secret here, guys, is that y2 minus y1 is the formula for delta y. And x2 minus x1 is the formula for delta x. So we've actually been using this formula subconsciously the whole time when we're calculating change in our heads. So this is just the really formal way of doing it. So we've only got a little bit of time left, so let's quick run through this. So I'm going to designate 2 points, point 1 and point 2. Let's say point 1 and point 2. Do you think it matters which ones? It doesn't. It doesn't matter which ones as long as you're consistent. That means that this is x1, and this is y1, this is x2, and this is y2. Very important that you do not get those mixed up. Once you designate the point, then the x1, y1s have to stay consistent. You can designate the points any way you want, but you have to label the x's and y's this way once you've done that. So let's just solve for m. y2 is -5 minus y1 is -3. Using your brackets, please, or you will mess up the negatives. Okay, x2 is 2 minus x1 is 1. -5 minus -3. That becomes -5 plus 3. -5 plus 3 is -2. 2 minus 1 is 1. And we say m equals -2 over 1. And look, we're right.